According to the UN Food Program, 130 million people will be in acute food insecurity by the end of 2020. Now, that's on top of the already 135 million people that were food insecure before the end of 2019. So, what does that mean? I mean, we've all seen the news. COVID food shortages. It's hard for farmers to operate normally with COVID restrictions. Food shortages in general in the last 30 years, 50 years, and even century. Food shortages, famine, and things like that have been a focus of institutions like the UN, the Peace Corps. All sorts of organizations have been striving to cure food hunger across the world. It's just something we've been seeing more locally these days, and it's becoming more apparent that it's an issue. So, I'd like to talk to you today about something called bioluminescent film. What is a bioluminescent film? Well, a bioluminescent film is a nanotechnology, and that nanotechnology basically converts the bright white and UV and blue light of sunlight, and it converts it into a more photosynthetically viable red light. So let me give you an example. This is the sun. It's really bright, it's kind of harsh, and sometimes when you spend too much time in the sun, you get sunburned. But when you put a nice little screen over it, makes it a lot more tolerable. Almost like sunglasses too, sunscreen, things like that, or really just a colored glass. But this colored glass is special. And what's special about the colored glass? Well, for starters, the sun is a lot bigger than this light. And the other thing is, the technology that forms the little particles that turn the light red are so small that it would take 100,000 of them to fit across the follicle of a hair. That's really tiny. So when you take a lot of them and you lay them out in liquid form and you make a sheet of nanoparticles, you put that sheet in between common use agricultural polycoating or polyplastic that's weather tolerable, that won't fall apart, and you make gigantic sheets of these nanoparticles that can be spread out over gigantic canopies of plants. And when you change light on a scale like that, it can really help plants grow. So, according to the Arc Center for Excellence of Translational Photosynthesis, plants are actually supposed to crave light. But when you have too much light, it creates free radicals. And free radicals can be harmful to the plants, and they can also be harmful to people. So, you got to take care of the people growing the plants, but you also got to take care of the plants as well. So, when you put this bioluminescent film in between the sunlight, which is a little too strong, and the plants or the people, really helps out. It's helps the plants grow. And when plants grow more, people eat more, and it solves the problem that we're having right now with food insecurity. But it's not just that simple, So, how much does it help? Well, according to Horta Daily News, can increase yields for most plants like tomatoes, cucumbers, and the other plants that were studied. Very basic things, household vegetables, if you will. It increased most of those things by 20%. That's it's pretty big, because when you have a 20% increase across the entire scope of global agriculture, that would easily feed everyone that's in hunger right now. So that's a big point right there. But what's so hard about making it? Well, one, it's really expensive. Two, the technology it takes to build it is really advanced. We're talking PhDs in physics, quantum physics, chemical engineering, bioengineering. All of these things have to be coupled together to bring this cutting edge technology to the forefront of everyday use. But it's already in use technically. But where? TVs. If you've ever seen a plasma screen TV or an LCD TV, then you've seen nanotechnology and nanoparticle prisms like the ones I'm talking about. And that's a great term to come up with a prism. So when you think of these little cylindrical things that I'm talking about, they're so small you can't even see them. But related to a prism, white light comes through, and when it goes out the other side, it's colored. And so when you apply that to a TV, it's the same concept. There's light going through these tiny little particles that are specific sizes, and when we see it on the other end of the TV, it looks like a picture. Pretty wild. So, we got the problem, we got the solution, but why isn't it fixed? It's still here. Well, a report from Science Mag claimed that it's like finding a vaccine for a virus, honestly, at this point. There's so many things going on, but it takes so many different tools all applied at once on a global scale to fix a problem like that. So, things are hard. But on the other hand, Nanosis Labs, one of the leading innovators of bioluminescent film, said that the greenhouse cover film market produces 20 times more area than the display industry, and by display industry I mean TVs, and grows double digits on an annual basis. So there is an effort to bring this solution on a mass scale, but it just takes time to move at that kind of pace. So what do we do in the meantime? Well, you just wait, like you just did. But don't feel discouraged. Just like the TVs, this technology is everywhere. It's constantly advancing, and with implementation, within a few years, the things I'm talking about, the solutions that could be put in place, could actually be realistic. At the moment, current technology is being advanced even further past agricultural studies. In 2019, NASA awarded a contract to develop greenhouse films for space missions that would be implemented in late 2019. The second contract was issued for $750,000 for further experimentation because the first trial was successful. So, growing food on Earth, one thing, but growing food on outer space, another thing. Pretty wild. So not only would we be curing problems with hunger here on Earth, but we're also advancing past that to where people could potentially inhabit other planets.